With advances in data collection and plummeting storage costs, today it is easier and more practical to collect and store data than ever before. Some estimates are helpful when trying to comprehend the massive information and data that organizations have at their fingertips. For example, Twitter produces hundreds of millions of tweets every day on average. There are billions of Facebook likes and similarly billions of daily Google searches. Now notice that not only has the data collection become easier, but also the cost of saving the collected data has plummeted over the years. According to one statistics from 2012, a gigabyte of data storage that used to cost roughly $19 back in 2000 roughly costs 7 cents as of the third quarter of 2012. Now it's important to notice that having this data sitting in the repositories of organizations without being looked at, without being analyzed, is almost like an unutilized asset. And that is exactly where the statistician, the data scientist, the analyst, or in general a quantitative professional passionate and skilled in the analysis of data comes to rescue. Now I will provide several examples where you can see how organizations are using data for predictive purposes. Now, one interesting example is from real estate, pricing and valuation of real estate properties. Among the data-rich companies is Zillow, an online real estate database company established in 2006 that hosts information on over 100 million homes in the United States. Zillow generates revenue by selling advertising on internet and mobile platforms, connects homeowners, renters, buyers and sellers with real estate professionals. Daily, there are over 1 million models that are run at Zillow to help the company come up with its recommendations and estimates. It produces the Z-estimate, an estimate of how much a home is worth based on publicly available information. It basically is a prediction of sales price based on a list of characteristics pertaining to a house. Another example of predictive modeling relates to call center management. Now, a call center is an office that is responsible for answering and addressing incoming telephone calls. Organizations utilize either in-house call centers or outsource the work to external call centers. In either case, for an effective operation of a call center, the management of the center needs to have a clear picture of the volume of the incoming calls each day, every day. Indeed, in the United States, students generally receive their admission letters during the months of March to May and start to make decisions on financing their education right around that time. Often students, their parents, contact student lenders for quotes regarding various loan products. There needs to be sufficient staff to answer those incoming calls at the call centers, and thus effective employee scheduling is crucial for a smooth operation of a call center. Accurate prediction of the incoming call volume can be crucial for that purpose. Among the data-intensive companies that actually utilize predictive methods in their business operations, some of the notable ones are the ones which use their recommendation engines to suggest to their members what to watch, listen, read, or consume by and large. Take, for example, companies such as Amazon or Netflix, where customer satisfaction, at least to a certain extent, is dependent on how effective the recommendation engines will guess what the next best product to suggest is, be it a book by John Steinbeck, an energy-efficient humidifier for your home, or the latest movie by Paul Thomas Anderson, which I haven't watched yet. Recommendation engines utilize predictive methods. Other examples of business organizations that heavily utilize predictive methods are financial institutions such as banks. Collecting and storing rich data on their customers, banks use predictive analytics to determine the likelihood of a loan seeker with a given characteristics to default on her or his loan. Having accurate predictions can help banks determine whether extending a loan to a customer is in bank's best interest. This is an example of credit risk modeling. In this and many other arenas, predictive approaches are carefully developed and then often automated to provide solutions as a matter of a click of a button. Such automatic solutions are more cost-effective for organizations than the more manual analysis of data that once were underlying the decision-making. You may have noticed that among the examples listed in the previous slide, the first two are different in their objective than the last two. The difference is that the former relate to the prediction of a quantitative outcome, example, the sales price of a property or the incoming call volume at the call center, while the latter is about the prediction of a categorical variable, for instance, which of the products should be suggested to a customer by a recommendation engine, or whether loan seeker defaults if the bank extends a loan. In fact, those are the two large families of predictive problems. One family is concerned with predicting a quantitative outcome, while the other family is concerned with predicting the class of a categorical variable. The former is often referred to as the family of regression problems, while the latter is referred to as the family of classification problems. These two together are often tackled using the so-called supervised learning methods. Remember, always consider the type of the variables that you have at your disposal when thinking of how to approach the problem you are solving quantitatively. The regression and classification problems, which are tackled using supervised learning methods, are represented as models. We will study models using an example to predict the amount of time a patent application undergoes an examination to become a granted patent. The background on patenting process will be outlined in the next session. But first, complete the quiz.